Hello, everybody. Now let's solve problem 3.27 from the textbook. This problem says to use mesh analysis to determine the amount of power supplied by the voltage source in this circuit to the rest of the circuit. So we have a voltage source right here, and we want to find the power that it supplies to the rest of this circuit on this side. And we're also supposed to use mesh analysis. So let's get started. In mesh analysis, let's first create these mesh currents. We got mesh current I1, mesh current I2, and mesh current I3 as labeled in the circuit. Now let's make some equations to get this started. So we can see right here, right, that the I1 is going to be equal to 9 amps. And this is because we have the current source. Now for I2 and for I3, let's look at this. Let's look at these two mesh currents and let's make some KVLs, right? So remember for the mesh analysis, we're going to be writing KVLs. So we're going to be writing some loops here. So let's start here. And let's say that we have a 2 ohm resistor, right? So going up over the 2 ohm resistor, we have current I2, right, going this way, and I1 going this way. So we have 2 ohms multiplied by plus I1 minus plus I2 minus I1, since they're going in the opposite direction. Then down on the other side, we have I2 minus I3, since again, these are going to be going in the opposite direction here. And that is going to be equal to 0 ohms, right? So this, we have 2 resistors in this loop, so we've made our KVL. Now let's make a third equation using this last loop. So we have a 4 ohm resistor, 8 ohm resistor, and the 40 volt source. So let's say we have this 4 ohm resistor right here. So we have I3 going through it, and then I2 in the opposite direction. So 4 ohms multiplied by I3 minus I2, that quantity. Then here we have just I3, just mesh current I3 through that 8 ohm resistor plus 40 volts. So we have that 40 volt source. So we've made another KVL. So now we have 3 equations and 3 unknowns. So let's solve them. In the videos, you've seen some ways that you could solve this using a matrix analysis, but I'm just going to solve this using your basic reduction. So first, I'm going to solve for I2 using equation 2. And when I simplify this, I get I2, mesh current I2 equals 18 volts plus 4 times I3 divided by 6. Now, let's simplify equation 3 a little bit, and we get minus 4 times I2 plus 12 times I3 plus 40. So just by distributing this 4 through here, we can simplify a little bit down to here. Now that we have a equation that's simplified with I2, and we also have an expression for I2, let's substitute this in. So let's take this expression and let's put it right here and solve for I3. So if we do this, it will take several steps, but if you solve for I3, we will get minus 3 amps. So we have I3 is minus 3 amps. So it turns out we drew the arrow in the wrong direction, but that's okay. Now we know what I3 is, right? So now we can solve for I2 by substituting our I3 back into our expression for I2. And what we will get, right? So we have I3 here, and we know from the previous problem, right, that I3 is minus 3 amps. So we're just going to substitute in minus 3 amps. And when we solve, we get I2 is going to be equal to 1 amp. All right, great. So now we know what the currents are. And we didn't really need to solve for I1, or I2, but we just did that for fun, just so I could show you how to do the mesh analysis. Now that we know what I3 is, we know that it's minus 3. So let's find the power. So just like before, we have the power is equal to the current going into that positive terminal multiplied by the voltage. So by convention, we have minus 3 amps multiplied by 40 volts, which is 100 and minus 120 watts. Since the power is less than 0, this means that this source, right, is a supplier of power into the rest of the circuit. I hope this helps you understand mesh analysis a little bit better, and I will see you all in the next video. Goodbye.